right, so this is the first topic of today, deploying R for production. We're going to give a high-level overview and some technical details on how to do this and show a lot of examples. The intention is not to teach you exactly how to do it, but to show you what can be done and how you might go about it, and also give you some things, some example files that you can then try on your own. Before we get into that, few words about myself. I work here at IBM as a consultant, and my background is in IT. I started as a developer and moving into IT architecture type of roles. Last 5 or 6 years I have focused primarily on data analysis and machine learning. First in the IT domain, looking at servers and networks and that sort of data, but then transitioning into other business related domains. And I've worked in several projects with predictive maintenance, trying to predict when machinery and industrial things will break down or have problems. So for instance, this pictures from a project we did with Atlas Copco, trying to predict when there would be any problems with their top of the line drilling rigs, as you see there, but also looking at anomalies and spotting unusual behavior in those machines. So that's basically me. So the main question I would like to try to answer today is, can we deploy R code? Because I think there's still a little bit of a question mark around that in some areas. Not for me, obviously. I wouldn't be here if that was the case. But I still hear people having a little bit of hesitation around this. So we will look at why would we want to deploy R code? How can we do it? Will it scale? What about security? Trying to cover a little bit of all of those pieces. But before we go into the how, I would like to maybe ask a little bit, okay, why would we want to do this? So the normal, very common use case when we work with R, we have some data on our laptops, we have training and testing data, we build a model, we run it, and we create some model asset. It can be a machine learning model or some other thing. But in many cases, for that model to be actually benefit to our customers, we work as consultants for our customers, so for that to actually add some value, some business value, many times it needs to run somewhere. It doesn't do any good sitting on my hard drive, so it needs to be in some IT system, because that is typically where we have incoming data, and the outcome of that IT system might be predictions or decisions, recommendations, or even visualizations, right? So things that we may want to deploy are, for instance, models that should be deployed so they can score incoming data, the visualizations. We might also have written programs that do data preparation and feature extraction, etc. And those things we need to do on incoming data as well, right? So they may run in the production system to process newly incoming data. In some cases, actually, we need to deploy it because we need to validate the model with more data than we have on our local machines. It could be that we require larger volumes of data or data that we can't have on our machines, etc., etc. So that's another reason. So there are many reasons why we are not satisfied when we have built a model that runs well on my machine and looks good on a PowerPoint slide. So we need to move further. And another question we might ask, should we deploy the R code or should we rewrite the R code? Some people say, oh, well, we shouldn't deploy R, let's rewrite this in I don't know, Java or Scala or something. So let me give a little pros and cons here. So why we would want to deploy R code? The most obvious one, of course, is that we want to reuse the code that we have already written. It runs on my machine, right? It does what it should, and we have verified it so it worked. So if we can reuse that code, of course we're saving that effort. But we also get consistency, and what I mean by that here is that if we have used some libraries and some R code on my machine to build a model and verify that, if we translate that to another language, we might use other libraries, etc., etc. We're not guaranteed to get the exact same results. In many cases we will, but not in all cases, and that is of course a reason for, could be a reason for concern, and we would need to test very carefully to make sure that our rewrite is exactly doing the same that we have already validated, and that is a piece of effort and it's easy to get that wrong. I would also say that it's easier to maintain the R code if we just put it in production, because otherwise if you translate it, most of the times writing some code and then deploying it, or creating a model and deploying it, is not a one-off thing. It's not something that we do once and then it is done. We work iteratively all the time. So once I have deployed a model, I will make some changes to my R code. I will improve it. I will add features, etc., etc., etc. So if we have translated that model into Java, all those changes that I do then on the R code needs to be translated as well. And that's a piece of work, and it's also a source of potential errors. So to some extent, it's much easier. We can have the same R code, make it easier to merge in my changes that I do. But there could be also good reasons to actually rewrite stuff as well. So one thing, many times, especially at bigger customers, bigger accounts, there will be separate departments having responsibility of the IT landscape and the IT applications, being accountable that they are up and running, etc., etc. And they, for very good reasons, will want to minimize the complexity of those production systems. And adding another technology in that is adding some complexity and not reducing it. So that could be a reason for them to push back on this, that they don't have R in production today, and adding something, they're reluctant to do that. And it could be for the reason of complexity, but it could also be for that they don't have skills. So these people, these teams, might be responsible to fix incidents that happen out of office hours, etc., where we data scientists are asleep at home, and we don't want to be called in the middle of the night. So they might have responsibility to fix things, and in that case they need to have the skills to work with the code, and they might not have, so that can be also a showstopper. And final point is related to performance, and I'll touch again on performance later because I think it deserves some attention. But let me say at this stage that if you have some extreme performance requirements, especially related to latency, that you want the result really, really quickly, that can be something that can be difficult to achieve in R. But we'll talk more about R performance later. Spoiler alert, it's not as bad as you might think, so we'll get back to that. But still, so there are some good reasons to deploy our code, and there are sometimes really valuable, valid arguments why you might want to rewrite it. So you can't say you should or you shouldn't. It depends on the situation. So at this point, I would like to get into the how. So how can we do this? And Mamar mentioned cloud many times in his short introduction, and this is where we do our work mainly. There are also private clouds you can run in a secure data center, that sort of thing. But we work with clouds. And the key to deploying stuff, including R code, are basically two enabling technologies that you might have come across, Docker and Kubernetes. So first a little bit of poll. Who has done something with Docker, like a tutorial or at work? Yeah, about half. And Kubernetes, same question. Fewer. Okay, good. So what I'll do here, I'm not going to teach you how to do Docker or Kubernetes, but I will show you the steps. I will show you example code configuration. So and you will get the slides. You will get all these example codes. It's all on my public GitHub, so you can play with it later on. But the intention here is to give an overview, what is possible, and also a feeling how difficult is it, because my point is it's not that difficult to do it. So extremely lightweight introduction to Docker for those that haven't come across that. Docker is really a way of packaging and running software components. So it allows us to package something that we have built into a piece that we call an image that we can then run in something that we call a container, and that will run the code that we have developed. And some good properties with this is that it contains all the dependencies that are needed. So if I have written something in R, the version of R that I need is in there as a dependency. Also all the libraries are in there, and the system libraries that are needed are all in there. So if I run it on my machine here, where I have a different version of R, different libraries, different etc., it doesn't matter. There is no conflict because the Docker container contains everything that is needed. And that is absolutely key. So I can have multiple containers running on the same machine with completely different prerequisites, and they will all just work. And they're also really lightweight compared to virtual machines. I mean, we have been using virtual machines for ages, but if you have tried it, you know how quick it is, because you need to boot it up and you need to install the operating system. The disk image will be 20 gigabytes and it will just take like a minute to start, etc., etc. Docker images are not like that. The actual image doesn't have to contain the full operating system. It relies on other images that do that, that contain that. And they're really, really quick to start. They start almost instantaneously. And you can stop them, you can restart them how many times you like. So they're really lightweight in that sense.